All right, for today I'm going to go over the the practice test, and show how to do everything, make sure we're okay on everything. So on the first one, this is on section 9.2 and 9.4, the first page of the practice test. And if you look at this, again, this is read, the function of x is defined by if negative x is less than x and less than or equal to negative 2, then our function gives us 4. If x is greater than negative 2 but less than or equal to 3, then we use the function x squared plus 3. And if x is greater than 3 but less than infinity, so in other words greater than 3, then I want to use this function. So they asked me to find f of negative 3. So I go up here, negative 3 is less than negative 2, so that would tell me that f, and you just write it that way, f of negative 3 equals, and our function tells us we get out 4. Then for f of 3, so f of 3, now we go up here, and 3 would be equal to 3, so we would use this rule, so we plug 3 in. 3 squared is 9, plus 3 is 12. And the last one, f of 9, so 9 is greater than 3, so we're going to use this rule. So we take 2/3 times 9, well 3, I plug in 9 in here, 3 goes into 9 3 times, and 3 times 2 is 6, plus 5 is 11. So that would be problem number 1. Problem number 2 asks us to graph the function. So when we go to graph this function, again, this is the same thing as what's up above, we're just now going to graph it. So again, we start with the value x is less than or equal to negative 2. Since it's less than or equal to, we're going to put a closed circle. And so we go to negative 2 for the x value, and this function tells us we're going to get out 4. And so we put a closed circle at negative 2, 4. And then it's always going to be 4 as I go to the left of negative 2. So it looks like that. Now we have to do the next part of the function. So x squared plus 3, we're going to start at negative 2, but it's greater than that, so we'll put an open circle. So we plug in negative 2. Negative 2 squared is 4. 4 plus 3 is 7. So at negative 2, we're at 7, and that would be an open circle. And so now we know this is a parabola because it's quadratic, but let's just plug in numbers. So let's plug in negative 1. So negative 1 squared is 1, plus 3 is 4. So at negative 1, we're at 4. So we put a dot there. At 0, 0 squared is 0, plus 3 is 3. Plug in 1, again we're at 4. At 2, we're going to be at 7 again. And if I plug in 3, that would be at 12, so that goes slightly off the graph, and that would be a closed circle. And now we can just draw that parabola in, and it would look like that, ending right there. And then lastly, we go to the last function, we plug in 3 again, it would be an open circle. Well, the 3's cancel, so we get 2 plus 5 is 7. So at 3, we're at 7, and that would be an open circle, because it can't be that. And then remember, you can just use the slope. The slope is 2/3, so that would be up 2 over 3. And I can draw my line now for that part of the graph. So that gives me the 3 parts of the function graph. Number 3 is on the back of this, so we're going to skip over to 4. 4 says, describe a situation that could be reflected in the graph. Now I know this is hard to see on here, but you should be able to read it on your papers. This is the miles from home, and this is the time of day. And so you can see here, from 6 in the morning till 8 in the morning, we're at home. And so a good description of this was, most of you in the mornings get up and you head to school. So it takes us to school for that approximately 8:35 time. We stay at school till lunch, and then maybe we go out to lunch, which is, let's say, further than home, not closer to home. And then we come back to school after lunch. And then we stay at school till the end of the day. And then the graph shows us going further away from home, so maybe that is you go to a friend's house, and once you get there, maybe you walk there, and then you walk back, and then you're at school again, so maybe you came back for a game and stayed till the game was over, and then you went home for the evening. So there's lots of different ways you could describe this, but some description that fits that graph for why you would be, and it could be a weekend that you went somewhere. There's a variety of answers that would work for that, just so it fits the graph. So number three, now remember on your papers you were supposed to put a negative sign in here, and it says write a function that can represent the data in the table shown. So what we're just trying to do is come up with a rule like our f of x, but since we did t and w, you might, just so you don't have to explain it, do w of t. And then you just have to find out what's happening every time. So to go from negative 16 to negative 4, I could add 12, and that would get me there, but 0 plus 12 is not 0. I could divide by 4 to get from negative 16 to negative 4, and 0 divided by 4 is also 0, and 12 divided by 4 is 3, and 100 divided by 24 divided by 4 is also 4. So on all of these, we're dividing by 4, so our rule would be t, which is where we're plugging in the number, and then we divide by 4 to get our rule. On this next one, it says a car is driven 40 miles for 5 hours, 25 miles per hour for the next 3 hours, and 60 miles for 3 hours after that. Graph the function that best represents the speed of the car. So on this, again, I did hours across the bottom. And then when I did it by 5 going up. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and our top number is 60. And so a car is driven for 40 miles an hour for 5 hours. So I go up to 40, right here, and we go for 5 hours, 1, 2, 3, 4, 5. And so that would show the 5 hours of 40. And then we go down to 25 for the next 3 hours, so we get down to 25. I'm going to put an open circle there because it started, again, it'd be an open circle at 0 because you can't be going at 0 hours. We're going at 60 for the first 5. So open circle here, and then we go at 25 for 3 hours. So 1, 2, 3, close circle, and then we jump up to 60 miles per hour, open circle, and it stays at that for 3 hours. So that's just a step function that gives you a graph that looks something to that effect. So those are our piecewise functions that we had a variety of things to do with, and that was 9.2. Then we went into 9.4, which was working with functions. So now remember when you work with these. So f plus g of x, that tells us that we want to add the two functions together. So we're going to take function f, which is 5x squared minus 3x plus 1, and we're going to add that to the function 2x plus 3. So if I write that in, 5x squared minus 3x plus 1 plus the second function, 2x plus 3. Now remember, just because I put the parentheses doesn't mean we use the FOIL or claw method on this. We just combine like terms when we add. So there are no other 5x squareds, or x squareds. We have a minus 3x and a plus 2x, which is a minus x. And we have 1 plus 3, which is 4. And so our f plus g of x would be 5x squared minus x plus 4. Now we have to do g minus f. Now, it's really important with subtraction to do the order right. So we take 2x plus 3 minus 5x squared minus 3x plus 1. Now with minus signs, it's much more important that we put those in parentheses, because remember that minus is going to change the sign of everything in that parentheses. So my suggestion, again, is to change that subtraction to addition, change the sign of everything in the parentheses, and now it just becomes an addition problem. So again, we don't have any other x squared, so negative 5x squared. 2x plus 3x is a plus 5x, and 3 plus a negative 1 is 2. And so we get negative 5x squared plus 5x plus 2. Then we have f of g. or f times g of x. So now we're going to take the two functions. And now we do distribute this, because it is multiplication. So I'm going to do the claw. 5x squared times 2x is 10x cubed. 5x squared times 3 is 15x squared. Then we do negative 3x times both. So negative 3x times 2x is a negative 6x. And negative 3x times 3 is a negative 9x. And then lastly, 1 times both. So 1 times 2x is 2x. And 1 times 3 is 3. So now we combine like terms. There are no other x cubes. 10x cubed. 15x squared, there are no other, this would have been minus 6x squared. So we get 15 minus 6 is a 9x squared. And then negative 9x plus 2x is a negative 7x. And there are no other constants, so we get 10x cubed plus 9x squared minus 7x plus 3. All right. The next one is division. So with division, we want to take function of f, 5x squared minus 3x plus 1, divided by 2x plus 3. Now remember, when you do division, you should always check and see if you can factor that, but if you do the x method, 5 and negative 3, there are no numbers that multiply together to give you 5 and subtract to give you negative 3, or add up to give you negative 3. So that would be, there's nothing to do on that. We would just put 5x squared minus 3x plus 1 over 2x plus 3. And we're done. And then the last one is the composition of functions. And it says f of g of negative 3. Now you have two ways you can do this. You can do f of g first, and that would be, remember when you do a composition, it means you take x, the g of x, and every time you come to x in f of x, you replace that. So one way to do it would be to go, and when we come to this x squared, we replace it with the 2x plus 3. So 2x plus 3 squared minus 3, and again we have the x, so we plug that in with 2x plus 3. And then we have the 1. And then you would simplify all this and then plug in negative 3. So you'd have to take that 2x plus 3 and FOIL that. And that would give us 4x squared plus 12x plus 9. Distribute the negative 3x, negative 6x minus 9 plus 1. Then you would have to distribute the 5 and get 20x squared plus 60x plus 45 minus 6x minus 9 plus 1. And then you could combine like terms to simplify that and then plug negative 3 in. So you can see there's a lot of work to do it that way. The way I would advise doing it is the other way, and that is that you take negative 3 and you plug it into g. So I go up here and I plug in negative 3. 2 times negative 3 is negative 6, plus 3 is negative 3. Then I take that negative 3 and I plug it in to f. So negative 3 squared is 9. 5 times 9 is 45. Negative 3 times the negative 3 is a plus 9. And then plus 1, and so we get 45 plus 9 plus 1 is 55. And so that would equal 55. You would get the same answer if we did this right. If we look at this, that would simplify to 20x squared. 60 minus 6 would be a plus 54x. And then plus 45 minus 9 would be 36, plus 1 would be 37. So if I've done that right, if I plug in negative 3 here, that would be 9 times 120 would be 180. 54 times negative 3 would be a negative 162. If I did that right. So that would be 180 minus 162 is 18, and 18 plus 37 is 55. So we got the same answer, but you can see a lot more work to do the function first and then plug in the number than if you plug in the numbers first and then put it in the function. And then this last one, it says f of x is 1 over x minus 5, and it says find g of f of x. So that tells me, remember, the second function I put into the first one. So I'm going to put that in for x. So it becomes 3 times 1 over x minus 5 minus 2. Now we should simplify this. Remember, this 3 is like 3 over 1, so I just multiply it with fractions straight across the top. So I get 3 over x minus 5 minus 2. That would be my function. So g of f of x equals 3 times x minus 5 minus 2. And then lastly, it asks us to state the domain. Remember, the domain is the x value. So the question is there any number I can't put in for x? And since the x is in the denominator, remember the denominator cannot equal 0. So x could not be equal to 5 because 5 minus 5 is 0. And so my domain is x cannot equal 5. It can be anything else, it just can't be 5. So that would be for 9.2 and 9.4. And then the second part of the test is Unit 6B, which is 12.3 and 12.4. Now, this was on arithmetic and geometric sequences. One thing I think is really nice to do as you do this is just to have the rules handy so you can go through. So I've got all the rules sitting here, so I know I can look at those and decide what I'm doing. So on this first part, it asks you to identify each sequence, if each sequence is arithmetic or geometric, and then find the missing terms of each sequence. So remember, for arithmetic, you subtract. A2 minus A1 gives me my common difference. So 12.5 minus 13.8 is a negative 1.3. And if I subtract 1.3 from 12.5, I get 11.2, so that works. Subtract 1.3. If I was to do a geometric, that would be 12.5 divided by 13.8. And that would be point. So if you did the geometric, so this was my A2 minus A1. If I did my A2 divided by A1, we get 0.905797. But anyway, if I take 12.5 times that, I get 11.3, not 11.2. So it's not geometric. So we can assume now that this is arithmetic. And now we just subtract 1.3, so that would be 9.9. Subtract 1.3 would be 8.6. Subtract another 1.3 would be 7.3, so it works. So now let's try the second one. So again, I can do the A2 minus A1. And 7.5 minus 3 is 4.5. Well, I could add 4.5 to this, and I'd get 12, but 12 plus 4.5 is not going to give me 46.25, so that doesn't work. So let's take A2 divided by A1, and if we take 7.5 and divide that by 3, we get 2.5. So now let's try that. 7.5 times 2.5, 18.75. And times that by 2.5, and we get 46.875 times 2.5 gives us 117.1875, and so we know this is geometric. So let's go to 3. It says find the 12th term of an arithmetic sequence where A3 is negative 9 and A7 is equal to 35. So again, we know this is arithmetic because they tell us in the problem. So we're looking at these formulas. But we have A3 and A7. So there's two ways to do this, and I'll show you both ways. So the way I would recommend is I just make this A sub 1. 7 is 4 above 3, so 4 above A1, this would become A5, and then we use our formula, A sub n equals A sub 1 plus n minus 1 to solve for D. So I'm going to plug this in for a sub n. So 35 equals a sub 1, which is now negative 9, plus our n is 5 now, because we made this a 5, so 5 minus 1 is 4 times d. Add 9, and we get 44 equals 4d. Divide by 4, so 11 equals d. And now we're going to go back and use the formula again to find a1. So we can use either one of these. I usually use the first one, so a3 I'm going to use, and that's negative 9 equals a1 plus, since we use this as a3, that would be 3 minus 1 is 2 times d, which is 11. And that would be negative 9 equals a1 plus 22. Subtract 22. So negative 31 equals a1. So now we know a1. So now we're going to use the formula for a third time to find a sub 12. A sub 12 is equal to a sub 1, which we said was negative 31. And then plus n, which is 12 minus 1 is 11 times 11. So we get a sub 12 equals negative 31 plus 121. So a sub 12 would equal 90. Now the other way you could do it is you can just use this as your an and say 35 and use this a3 here, negative 9. But then, since I don't change this to a1 and a5, then I just do 7 minus 3, your subscript numbers, times d. You can see the formula is the exact same as this formula. Okay, if we do it this way or this way, it ends up being the same thing. And then you can do the formulas the rest of the way the same. So now let's do a geometric sequence. So now I know that I'm going to use these formulas over here. And again, we're doing the same thing. Find the 12th term. Now, this one's a little easier because remember, we can do a2 divided by a1 equals r, but we can use any two successive numbers. So since we have a6 and a5, I would just do that and go 4 divided by 20 equals 5, and that, or excuse me, equals 1/5 or 0.2. So that's our r. And now we can work with the formulas. So again, I found r, and we want to find a sub 12, so we need to find a sub 1. So I'm going to make this a sub 5 20. So that's my a sub n equals, we don't know a sub 1, but we do know r is 0.2. And then our n minus 1, since we're saying this is 5, that would be 5 minus 1 is 4. So now we have to do 0.2 to the 4th power. And that gives me 20 equals 0.0016 a1. And divide 20 by that, and we get that a1 is 12,500. Now that we have a1, we can go back and plug it in again to find an. So we're trying to find a sub 12. Our a sub 1 is 12,500. Our r is 0.2 to the n minus 1, and our n is 12, so that would be to the 11. And we just type that into the calculator. And we get, now, so you know on the calculator you get 2.56 e to the negative 4th. Remember that e stands for exponential form. Sorry about that. So, sorry I had that low. So again, we did 4 divided by 20 at 1/5 or 0.2. We then plug that into the formula for a sub n. 20 equals a sub 1 times 0.2 to the fourth. We took 0.2 to the fourth and got 0.0016. And then 20 divided by that gave me the 12,500. So then to find a 12 sub 12, we put in a1 times 0.2 to the 11th power for the n minus 1. That gave me 2.56 e to the negative fourth. Now remember, this is scientific notation, so 10 to the negative fourth power, so that means move the decimal 4 places to the left. And so we get add 3 zeros, 256 would be our a to the 12th. Okay? Then we have a geometric sequence given here, and it says find the explicit rule. So that's our rule. When it says the explicit rule, they want the rule for a to the n, to find any number in the sequence. So we take our a1, again, we're using this rule here. We take our a sub 1, which is 2. We take our r, 10 divided by 2 is 5. And then to the n minus 1. That is our explicit rule for the sequence, and we can find any number in the sequence by using this rule. So then it asks us to find the 10th term, so we find a sub 10, and we just plug it into the rule. So that would be 10 minus 1 is 9. So a sub 10 equals 2 times 5 to the 9th power, which is 390,6250. So 3,906,250. And then it asks us to find the sum for the first 10 terms. So to find the sum for the first 10 terms, we now have to use this formula. So S sub 10 equals a sub 1, which was 2, times 1 minus r, which was 5, to the 10th power, divided by 1 minus 5. So if I do this on the calculator, we have 1 minus 5 to the 10th, which gives us a negative 9,765,624. 1 minus 5 gives us a negative 4, so we have to divide that by negative 4. And we get 2,441,406, and then we have to times that by 2. So our S of 10 is 4,882,812. Okay? And then the last page of this so again, this is another way to write the sum. This is our sum notation. It says, this tells us to find the sum from the first to the 12th. So we're just finding S of 12, and we use the formula just like we did last time. But we're using this formula because it's arithmetic. So, to find n, we know that's 12. And then to find a1, you just take and you plug 1 in. 3 times 1 is 3, minus 5 is a negative 2. Plus, and then to find a sub n, which is a sub 12, we plug 12 in. 3 times 12 is 36, minus 5 is 31. And we divide that by 2. And if you plug that into the calculator, you get 29 divided by 2 times 12, 174. So S of 12 is 174. Then on the last problem, it says the first row of an arena has 85 seats. Each subsequent row has 5 more seats than the row in front of it. So we're adding 5 each time, so we know it's arithmetic. So we're going to be using our arithmetic rules. It says how many seats are in the 11th row, so we're finding a sub 11. So we plug in a sub 1, first row had 85. And then plus n minus 1, so 11 minus 1 is 10, times d, and our d was it was getting 5 more every time. And so 85 plus 50, or a sub 11, would be 135 seats in the last row. And now we use the sum formula to find out the total seats in the first 11 rows. So S sub 11. So we get 11 times a sub 1, which we now know is 85, plus a sub 11, which is 135. And we divide that by 2. So 85 plus 135 is 220. Divided by 2 is 110. So we have 11 times 110. Well, we know 11 times 11 is 121, add the 0. So our S of 11 for the total seats in the first 11 rows is, sorry about that again. So again, we plugged in 85 for a sub 1, 135 for a sub 11, divided by 2, so that gave me the 220 divided by 2 is 110. 11 times 110, so we take the 11 times 11 is 121 and added the 0. So that's the test. That's what you're going to need to know for this test coming up. Make sure, again, these are the formulas that I would make sure I had on my 3x5 card for the test, along with anything you need to know about functions, whether it's addition, subtraction, multiplication, division, or composition of functions, and then the step functions to make sure you know how to graph those and read a graph. So hopefully this has helped, and study that to make sure you're ready for the test. Thank you.